Automotive Electronics Test 11. Is that one everybody's got? The tests that I passed out last week will be the ones we'll do this week. So I didn't give you new tests, but the ones that didn't get done last week will be done this week. And we're going to do Automotive Electronics Test 11, which you actually did test 10 last week when Adam was here. So let's go through this. Multiplexing networks allow several devices to share signals in a common conductor. Is that true or is that false? Is that true or is that false?
True.
That's true, isn't it? Okay. The true-false questions are basically... Did you know whenever I give a test, the true-false questions are the ones that people do the worst on? For some strange reason, there are only two choices. You know, how would you like to take a final exam with only two questions on it?
I would hate it.
I would love it.
What happens if you, Joe? What happens if you miss one of them?
You get a penalty, you fail.
Yeah, but you're wanting to take one, okay?
Hey,
all right. The ISO K-bus protocol allows for bidirectional communication on a single wire. That is true, believe it or not. ISO K-bus allows for. Now, why do we want it? Why do we want bidirectional communication? What good is it? Web. What good is bidirectional communication? Whenever you got a scan tool plugged into a car and you're wanting to see if something works, like on this one of these Dodges, let's Neon or whatever kind of vehicle, you can actually go into your special test mode and you can tell things to happen. You can tell your scan tool, I want you to fire the coil, or you can tell it, I want you to click this relay. Now, whatever. If you tell it to click the relay and it tells you it's clicking the relay and the relay ain't clicking, what do you know? You know that the software and the computer's working, but you got to make sure that the wire is good from the computer all the way out the relay. So I'm going to go to the relay socket, if it's a relay. I'm going to pull it out of there, the wire that's supposed to be energizing that, and I'm going to take my test light or my logic probe or whatever I'm deciding I'm going to use, and I'm going to plug that thing in, and I want to see if this thing is actually blinking that. If it is, I know the wire is good from the engine controller out the relay, but I'm going to actually put a different relay in there. You know, maybe test the relay, put a different in there, see if it'll go click, click, click. That's what you're basically going to be doing right there. Okay, so you're going to be two-way communication is for troubleshooting purposes. EGR, like on her car, when you were fooling with that the other day, you can tell the EGR valve to open. On some of these GM cars that got electric EGR, you can actually go in there and you can say, open me EGR valve. And you're listening to the engine while it's opening, and I want to see if I'm hearing it starting to run rough. Or if it's a diesel with EGR on it, I want to see if it gets quiet. You see what I'm saying? So if you can tell it to do stuff, and you can get you're doing a rationality check of your own, you're saying, I'm going to see if this is actually happening when the computer is telling it to do it. So that's what two-way communication is about. Nemesis won't do that. Genesis will. That other scan tool I got that I keep in the trunk of my car will. Two-way communication is extremely important if you're a serious troubleshooter on any kind of engine control stuff, or even on, well, like door locks and stuff. Like on this Dodge Caravan that's sitting right out here the other day. I went in there and I said I wanted to operate the door locks. I could tell it to operate the door locks, and I'd say lock the driver's door, and it would go, unlock the driver's door. Boom. You can do that from the screen. You know, on some of them you can say turn on the windshield wipers, and it'll turn on the windshield wipers. You know, if you can tell it to do it, but it won't work the normal way, it gives you an idea of whether it's a switch or something like that. See, so that's something I need to get you guys ramped up on, so that whenever you troubleshoot it, you can tell what's wrong by using a scan tool with two-way communication. Look at inputs, look at outputs, all that kind of thing. Controller area network system can support baud rates of up to 5 megabits per second.
I think there would be more than that.
Well, 5 megabits per second is, pretty strong. How much is a megabit?
It's 1,000 bits. 1,000 bits.
That's a million. Kilobits is 1,000. Megabits is a million. So that's pretty strong, isn't it?
Yeah.
5 million bits per second is pretty good stuff. Not all CAN buses are that fast, though. Some of them are just 87 kilobits per second. All right, so anyway, that's actually 3. No, actually 3 is true. Some, controller, that system can support that. Basically, but it doesn't mean every CAN bus is that fast. Some CAN buses are faster than others. The fastest CAN buses are used on engine control and vehicle dynamics, stuff like anti-lock brakes and that kind of thing, because the decisions have to be made very, very fast. And you got smart boxes talking to each other and all that. Like, for instance, on the Power Stroke, the common rail injection stuff, the 6.4 that came out, the turbocharger, for the turbocharger, that actuator. It actually has got a special cooling system for it because it can get pretty hot. And it's a box with a little arm on it that moves the vanes in the turbocharger. And if the engine controller asks it for a different turbo angle, that box is liable to talk back on the CAN bus to the PCM and say, I'm not giving you anything until you turn me that pump on and cool me down a little bit because I'm hot. And so the PCM has to say, yes, sir, and turn the pump on and cool it down before it gets what it wants. See, so these things can argue with each other in certain circumstances. All right, now then, number 4 is Bluetooth technology allows several modules from different manufacturers to be connected using a standard high-definition transmission.
This is gonna throw me off, but I'm gonna say that's true.
Yeah, that's a strange question, and I really don't like the way it's worded. I don't like but see, several modules from different manufacturers. I would say that's true. Now, the guy that wrote the book doesn't like that. He calls it false, but I would say it was true. Just so you'll get it right, put false. But I would like to call him and ask him what in the Sam Hill he's talking about there. But, and because you and I both know what Bluetooth is. And, if you got Bluetooth on your car, anything that's Bluetooth that can hook up and talk. You know what I'm saying? So what in the Sam Hill is he talking about there? Yeah. Number 5, local interconnect network bus is part of a UART single master, multiple slave, not Singe master, single master, double slave, multiple slave, low speed network. And that's basically going to be true. You guys need to read this chapter. Lynn, did you read this chapter?
Not chapter 11, no.
No, okay. Well, you need to dig into that because this network stuff is all over the place. An F-35B Joint Strike Fighter takes 6 million lines of computer code in order to operate. A 2010 Ford Fusion takes 250 million lines of computer code. So we're working with computer code that goes beyond fighter jets in these cars nowadays. There's that much computer code difference in that. The fighter jet's a whole lot more fun to watch, but the car's got a lot more it's got to do, the computer has. Okay, let me see here. Each computer is connected to the data bus. Each computer connected to the data bus is called a mole.
Sure,
that's false. Yeah. Media-oriented system transport, MOST, cooperation data bus system uses fiber optics to transmit data. Does it? That's true. Let's see. Have you guys ever worked with any kind of fiber optics or anything?
It's very sensitive.
Do you know who it was that first demonstrated that voice transmissions could be carried using beams of light? Anybody know? The first person, he demonstrated it. He demonstrated it to a group of people that you could carry voice transmissions with a beam of light. It was Alexander Graham Bell, the guy that built the telephone. He showed them how you could make that happen. And that's how smart that guy was. All right, so let's see. They didn't have anything flexible that they could use back then, but he used a glass rod. Let me see. Let's see. Wireless networks use the use of one wire to transmit information.
No.
No. Number 9.
Wireless.
Yeah. Duh. Yeah. What about a wireless charger? You ever seen a wireless phone charger?
No,
I've seen one for a paintball gun.
Please. But now think about that. Have you ever seen a wireless phone charger?
Is that those mats?
How can you charge a charger? How can you charge a phone without wires?
I saw a commercial on television, and there were some people coming up with a wireless telephone charger.
Yeah, a way to charge it. Well, if you go over there, you can buy for about $8. Over there, it'll say wireless charger. Of course, it plugs into your cigarette lighter. It's got a wire that hooks up. They call it a wireless charger. I thought it was silly.
Don't they have the solar ones too? The solar chargers?
They do. Have you ever used a solar clothes dryer?
No.
Yeah, you have. Clothesline with clothespins in it.
Oh.
She fell in that. She fell in that head first, didn't she? Okay.
Well, I know they have those mats because you just put the phone on and it charges it.
Yeah, that's pretty cool.
That's
Yeah.
no real wires.
Yeah. But anyway, that's just something. Wireless networks use one wire. Anyway, I'm just making fun there. Multiplexing wiring system uses bus links that connect modules together. That's true. Controller area network was developed to supplement the local interconnect network bus system. No, that's false. It wasn't created for that. One of the things that they had to do was come up with a faster network. You might notice that the vehicles, well, like for instance, if you see a Ford vehicle that's got electronic throttle body, it's got a different kind of engine controller. Because they needed an engine controller that would, with a faster microprocessor, and the CAN bus communication has got to be faster because it needs to instantaneously do things when you tell it to do things. So they needed something that would talk really, really fast. And that picked up a lot of speed. Controller area network bus diagnostics is being discussed. Technician A says the first step is to verify the customer's complaint. Technician B says you must determine which bus network is at fault. That's C there. Because you got a whole bunch of buses on there. I've got an entire study that I like to, put people through when we have time on, bus diagnostics and everything. But basically, if you can pull the bus up on your schematic, and you notice that if you got one group of modules that's not talking, if they're all on the same bus, then something's either pull that bus to ground or you got a bad module. And basically what you're going to do is you're going to unplug all the modules from that bus with your scan tool plugged in. You're going to plug the modules in one at a time, typically. This is just a sort of a generic way of doing things. You plug one module at a time. All right, plum. All right, that one's talking. Whoop, that one's talking. Whoop, that one's talking. And then you plug this one in, the whole network goes down. Whoop, that module's not good. See what I'm saying? I mean, there's all kinds of different. How many of you guys have worked on computers, worked on PCs? All right, basically, if you've worked on your PCs, you kind of know what I'm talking about. You know what I mean? You're basically going to, if you've got a network card that you put in there or some other card that you plug in that pulls everything down and it doesn't boot up, you're basically, you have to substitute other cards or boot it up with a different, in a different way. Maybe let it use the video that's coming right off the motherboard instead of letting it come through the video card and all that. And it's just a troubleshooting thing. But you think of the whole car as a big computer network, or as a big motherboard if you want to go that route, But there's a ton. There's also a way you can go into your bus, and if you know what you disconnect your battery and you go with your meter into the two wires. If you got two wires coming from your network. Like all these Toyotas, I think the resistance, parallel resistance of all of those controllers have terminating resistors in them is like 60 ohms. You see, if it's less or more than that, you got a problem with inside one of the modules, or maybe a cut wire or something like that. And then you got to track it down beyond that. Read. The more you read on this, the smarter you're going to get, basically. Controller area network bus diagnostics are being discussed. Technician A says a scan tool is used to access the central gateway module for the bus network. Technician B says if the scan tool can communicate with the central gateway module, then the CAN C circuit has it faults. That's A only. Basically, the central gateway module is where you got a bunch of different networks with a bunch of different speeds, right? You got your CAN bus, your 5 megabit CAN bus, your 87 kilobit CAN bus. You got your other buses that run slower. All of those come together in a central gateway module, and that's the clearinghouse. That's Grand Central Station for your networks. Not every vehicle has got a central gateway module. See what I'm saying? You got to look at how the network's laid out, and you'll see it. This looks like a serious map with all these modules on it. I mean, there's all over the place. You're going to see modules that are tied together with twisted wires, and it's like a super highway of information that's going to. Every one of them has got access to all the same information, but they're smart enough to sort that out and only use the information they need. You got me? All right. This is not for the faint-hearted, okay? All of the following are facts about the controller area network bus diagnostics except, okay, this is going to take some reading here. A normal voltmeter reading on the CAN B plus circuit with the ignition and run position is between 280 and 920 millivolts. Is that right? That is right. A normal voltmeter reading on CAN B plus circuit with the ignition in the off position and the bus asleep is 0 volts. That's right. A normal voltmeter reading on a CAN B minus circuit with the ignition in the run position is between 4.08 and 4.72. That's right. This is the one that's wrong. A normal voltmeter reading on the CAN B minus circuit with the ignition off and the bus asleep is 0 volts. That's what he says anyway. What do you think about that? Is that silly or what?
Yeah.
Looks to me like he put exactly the same answer for B as he did D, doesn't it?
One's positive, one's negative, though.
Yeah, you're right about that.
Got volts going
Yeah.
through it?
Yeah. Okay, I'm going to leave that to you to dig that up because I'm not going to pull that stuff up off the top of my head and maybe tell you something's wrong. Just put D and you'll get the answer right. Controller area network bus diagnostics being discussed. Technician A, some modules do not set specific codes that isolate the type of fault. Technician B says the fault code indicates both CAN B plus and CAN B minus circuits are low or high. Total bus failure has occurred. Who's correct about that? That's going to be C on that one. There's also an interesting way that Mercedes is doing their doggone, basically they got all these little actuators right here under the dash. They got about 10 different actuators for the air conditioner. I don't know why they need that many, but they do. And the bus comes in here, goes from module to module, and comes out here and goes into the network. If this one is cut, it can still talk through that one. If this one is cut, it can still talk to that one. If both of them's cut, all these actuators go to sleep. But it can talk through either one. See what I'm saying? It's pretty cool how they did that one. Alright, we got a caller here. It's Tammy. Hey, Tammy.
Hey, Richard.
Yeah.
I got a question for you.
Okay, go ahead. Yeah. Yes, ma'am. Sure, yeah. For which, I mean, I've got a bunch of them. Which? Mm-hmm. Yes, ma'am. I will. Let me get in it. Sure, I'll go ahead and let me get through in my classroom here and I'll do that. Yes, ma'am. Help me remember to send her my list of textbooks, okay? She needs some, okay. Somebody help me remember that. If you don't, I'll forget it, because I'm addled. All right, let me see here. 15. Technician A says J1850 protocol is a Class B standard for OBD2. Technician B says the J1850 standard allows for 4 different versions based on baud rate. Who is right about that? That's A. That's A, basically. Technician A says ISO 9141-2 is not a network protocol. Protocol meaning a language, right? Not a network protocol since it can be used only for diagnostic purposes. Technician B says ISO 9141-2 is a Class B system that has a baud rate of 10.4 kilobits per second. Who is correct about that? That is C. Technician A says the LIN bus is a UART single master multi-slave low-speed network. Technician B says the local interconnect network was developed to take the place of the CAN bus system. That's A only. Technician A says the circuitry of the CAN bus usually consists of a pair of twisted wires. Technician B says for digital data to transfer, the CAN bus voltage is simultaneously pulled high on one circuit and low on the other. That's C. All right. Technician A. Oh, here's what's funny. On some of those Dodge trucks for a while, I mean, there was a time years ago when they had a twisted wire going from the smart junction box to somewhere under the hood. I don't remember all the details. And it was doing crazy things and it wasn't working right. And the fix for that was to disconnect the wires from one end and put more twists in them. Because there's a certain number of twists within a certain number of distance. It has to be there. You understand what I'm saying? That's strange, isn't it? That in order for it to have, to not be, they twist it around each other to keep electrical interference from jumbling up the signal. You see what I mean? Because if enough of that wire is just running linearly and it gets some stuff induced in it, it's going to wind up, going wacky and not sending you the right kind of signal. It's sort of like messing up the, the flow of traffic and everything. Okay. Technician A says modules on the media-oriented system transport data bus use LED photodiode and a MOST transceiver to communicate with a light signal. Technician B says a media-oriented system transport system uses fiber optics to transmit data at an extremely fast rate. That's C, basically. And you're going to have a lot of speed that's possible on a optical network that you will not be able to do on a wire network. That's why optic fibers. As a matter of fact, the internet connection between this building and the other one over there is optic fiber internet that we got going between the buildings over here. Technician A says wireless network can connect modules together to transmit information with the use of electromagnetic field. Technician B says Bluetooth technology allows several modules from different manufacturers to be connected using the standardized radio transmission. Yeah. I think the other question was a trick question. He just thrown a word in there that flipped us out or something.
So what is this one?
Yeah, that's actually going to be B only, I tell you, it's really something else that's a little bit annoying is whenever I used to have this thing in my car. Now the radio that's in my car Bluetooths to my phone automatically when I crank it up. And it was an aftermarket radio I put in there. It does a good job. And that stuff don't cost much anymore. But what would irritate me was when I had this thing that I would have in my car that I would turn it on and I'd be talking, it'd be a phone thing at a hands-free deal. If I happened to forget to turn that off when I got out of the car, because it wasn't hooked to the car's electrical system, I'd be in here somewhere and my phone would ring and I would say, hello, 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 and it'd be talking in my car because I forgot to turn it off. It's silly. All right. Let's see. What's each computer that's connected to each other in the data bus called?
Not a mole.
It's not a mole. What is it? It's a node.
Node.
Can you think node? Node. What does the acronym MUX stand for?
Multiplex.
Multiplexing. All right, number 23. What protocol is the Class B standard for OBD2?
J1850.
The J1850. Who established that standard, by the way?
Alexander Graham Bell.
Oh, please. That was the Society of American Engineers. Any J this or J that or J the other. Like, for instance, the AC machines that were supposed, the generation that exceeded the one, right as the one I got out here, were J2788. And then there's a J1930 protocol that talks about, not a protocol, but a J1930 regulation that says everybody's supposed to use the same abbreviations for all their sensors. An ECT sensor is always an ECT sensor on every car. They don't have it swapping around all over the place. Now, if it controls the engine and the transmission, it should be the PCM, which would be Powertrain Control Module. If it only controls the engine but it don't control the transmission, then it's the ECM, Engine Control Module, and the Transmission Control Module is a TCM. They had to do that. The alternator was suddenly being called the generator, if it's controlled by the PCM.
I never understood that.
Yeah, well, that's what they say. When I wrote that one article for Vistion that they were doing alternator rebuild, I was trying to call it a generator because that's what everybody wants to do nowadays. And Vistion, whenever they proofread the article I wrote for the magazine, they said, no, if we're going to call these an alternator. They don't want to call it a generator. They didn't like that. And these were the people who were building those things, so whatever. All right, let me see. That's a sort of a gray area where I don't think anybody's going to slap your hand no matter what. But all your textbooks are going to call it a generator, and your shop manuals will too. All right, so what module is used where all three bus networks connect together?
Lynn.
What is that?
I don't know. I said Lynn.
Making it up as it goes. What is it? Anybody know?
Nobody.
All right.
Oh,
What do you think? Would that be the central gateway module, you think?
It makes sense.
Don't you think that'd be central gateway? All right. What do you think?
I think that sounds good.
Hold on. All right, what question were we on?
we're on number 25 now.
Number 25 now, okay. Now then, number 25 in the media-oriented system transport data bus system, what changes light signals into voltage that's then transmitted to the most receivers?
It's a photodiode.
Photodiodes, that's a good answer. Number 26, what type of technology allows several modules from different manufacturers to connect using a standardized radio transmission? We've been talking about Bluetooth. Number 27, we got what system provides the ability to use a single circuit to distribute and share data between several control modules?
Two-way.
Multiplexing, right?
I knew that.
Number 28, what organization has defined different classes of protocols according to their baud rate? I just told you that answer a minute ago. Huh?
Hang on.
SAE.
Yeah. Yeah. No, that's the Society of American Engineers, buddy. All right. SAE, right?
Yeah, see?
Yeah.
Yes.
Number 29. I actually know some of those engineers from the Society of American Engineers. Number 29. In what model year are manufacturers required to use controller area network on their vehicles?
2005.
2008.
Close.
2008 is when they were required. Number 30. What are the three data bus classes for controller area network?
A, B, and C.
CAN A, B, and C. That's right.
Yes.
All right. Now, beginning with 31, these are essay questions. I thought about giving you guys 100 essay questions for your final. Would that be good? No, not really. I would not do that. You know how much hard that would be for me to grade that? Come on, guys. You know I'm not going to do that. All right. Number 31. What standards are the media-oriented transport most cooperation data bus systems based on, and how does it operate? Okay, now this is the answer. The media-oriented transport cooperation data bus system based on standards established by a cooperative effort between automotive manufacturers, suppliers, and software programs that resulted in a data system specifically designed for the data transmission of media-oriented data. Most uses fiber optics to transmit data at a fast data rate, 25 megabits per second. That is fast. You see the regular CAN bus has got 5 megabits per second, and this has got 25, which is 5 times as fast. Isn't that something? All right, now number 30.
Okay.
Number 32. What is multiplexing? Somebody tell me.
It is.
Oh,
It's a
ability to
system
use
that provides the
single
ability to
circuit
use a single circuit.
Yeah.
different control modules to share information.
Electrical signals are transmitted by peripheral serial bus instead of by conventional wires, and it allows several devices to share signals on a common conductor. The same wires hooked to a whole bunch of boxes. All the information is going to all those boxes. They sort it out and they pick out only what they need, right? It's pretty cool the way that works too, you know, if you get right down to it. What are the basic operation principles of controller area network bus systems? It supports higher baud rates, right?
Yes.
And it's a twisted pair of wires, and it allows for message prioritization between nodes. You got me? Okay, number 34. We got 2 more questions left. The central gateway module is used where all 3 CAN bus networks connect together, similar to a router in a computer network. This module allows data exchange between the different buses. In addition, the CGW is also the gateway to the CAN network for the scan tool. Everybody got that?
No.
Okay. All right. Joe, read the chapter. All right. The local interconnect network is a UART single master module, multiple slave module, low speed network where the module is located within a limited area. The LIN master module is connected to the CAN bus and controls the data transfer speed. That's the local interconnect bus, right? It's connected to and it controls the the data transfer speed. You got that?
Yep.
All right. Now that kind of stuff there. See, you're getting deeper and deeper into computer stuff with these newer cars, you know, and it's just not as simple as it was. You know, something's really weird. You kind of got an idea that you know what cars work like. Let me tell you about this for just a second. There was a 2005 Cobalt that this girl brought up here. She bought it for $1,000. It had been sitting in a barn. Had 40,000 miles on it. Been sitting in a barn for 2.5, 3 years, just sitting there.
Wow.
Dead battery and all that stuff. Now this car had originally been written up and photographed for Street Trends magazine. It was a cool looking little car. It had some fancy wheels on it originally, but it had, you know, dumb looking little unpainted wheels and tires that were too small for the car when it came up here because somebody took the wheels off of it. Okay, so it comes up here and it won't start. And there's been a little bit of rat damage in the wires up under here. But this thing is heavily networked. You know what I'm saying? It's a heavily networked car. And it's been sitting there. All right, so when they come up here, you can turn the key, you get nothing and all that. You know, you couldn't hear the fuel pump or anything. Well, somebody put the fuel pump in there wrong. On that Cobalt, you can unplug a fuel pump relay, look at it, plug it back into the wrong pins, which looks like it's in the right place, but it's not. You know, 2 of them are just empty cavities, and because it's, you know, it's just weird the way it's set up. Anyway, I got that straightened out. And we kept fooling with it, and we would start it up. We got it eventually, kept tinkering with it and fixing wires and stuff. We got it where it would start up. And if it stopped communicating, if the network went down while the engine was running, it didn't kill the engine. But when you switched the key off, the car would keep running because the network didn't know that you had switched the key off.
How about that?
Isn't that something? It's weird. The whole thing was strange. And all we did was we'd crank it up and let it run a while, and we would check it for codes, and we would clear them, and we were just doing all this stuff, and, you know, checking I was wondering if the rats had eaten the network, and we exhaustively looked at all that. We couldn't really see anything. There was some rat damage under the hood, but there wasn't any rat damage under the dash, and none of the, you know, network-related wires worked. Well, the longer we fooled with that car, and the more we let it run, and the more we messed with it, the more it started to straighten out. And the girl was saying, you know, what are we going to do about this? I said, well, we're going to run it for a while and maybe let it get used to talking to each other again.
Right.
Yeah. I mean, just let it get used to being used and everything. And did you know, and this is real, I can't explain all of this completely, but the more we fooled with that car, the more we cranked it, the more we shut it off, the more we messed with it, the more it started to wake up and act right. Now, I never read about that in a textbook anywhere, but that car did that. And I'm not saying that every car that you do network diagnostics on, that was a special case. It was a car that had been sitting in a daggum barn. You know what I mean? It hadn't been driven for a long time. And it was almost like these modules had to get reacquainted with one another again before they would get to where they would talk consistently. You know?
Then all the modules went out.
Now, one day, I was over at the Ford place. I was working around. They says, Philip is back there, and he's working on this big truck that doesn't, they had to put a speedometer in it, an instrument cluster in it, and it won't work. The odometer don't work, the speedometer don't work, none of the gauges work, but we know it's a good cluster. And it was a big truck. It was a Freightliner or something. I can't remember what kind of truck it was. And so I went over and I was just checking all the wires like I would, previously. And what I discovered on that dadgum thing was when you pull the instrument cluster out that was in there, and it was working, but it didn't work right. Something was wrong with it. I don't remember why I do. You put the other one back in there, then that engine control module, when you plug that other instrument cluster back in, it says, I don't know you, and I ain't talking to you until somebody does a marriage ceremony.
So you had to reprogram it.
Yeah, basically. But I mean, if you check everything and you're getting good signals everywhere, and yeah, they're going up there, but the engine controller would not send the data to that cluster because it says, how do I know that somebody ain't trying to steal me here? I'm not fooling. So anyway, we had to, I think we hooked if I remember right, we hooked the laptop to it, and we got a hold of whoever the Sterling or whoever, Freightliner, whoever, and they flashed it from up there in Peoria or somewhere.
Wow.
And we got it to wake up and come to life and all that kind of stuff. The same way, if you put an instrument cluster like on a 2004 Chevrolet pickup truck, you don't just pop an instrument cluster in there, plug the wires in and go. You got to program it. It's going to be dead as a hammer till you program it. That silly little power window switch computer thing, same way. You can plug all the wires in, everything will be right. If it's not programmed, it ain't going to roll no windows down, it ain't going to do nothing. Bobby Messick's 2007 Avalon, we had a battery cable off it, we put it back on, he goes, my moonroof don't work. Really? Seriously? We didn't know none of that, or did we? Well, when we got, then I got to investigating that, and I found out you had to reinitialize all the windows before the moonroof would wake up. And when you reinitialize all the windows and you taught those window motors what was the bottom and what was the top, then it says, okay, fine, you got that done, now I'll give you the moonroof back. Then the moonroof worked. See, we didn't have to do anything to the moonroof. We had to initialize the windows. The point I'm trying to make is, somebody thinks they're going to plow in here and fix these cars without no book. That's a joke. You know what I'm saying? You cannot intuitively do stuff like you used to be able to. When my dad hung up a shingle that said Foreign Car Garage in 1960 and just started fixing cars when he'd never really done it before and got good at it, that ain't happening today. There's entirely too much that you're going to have to do. And you might think you're smart enough to figure out anything. Well, that ain't happening. You better get some training. You better get some books. You got to have equipment. And you can actually put a set of brake pads on one. But if you're going to go too deep into it, you better doggone sure have the right kind of resources, and that would be your Identifix, your All Data, your Mitchell, whatever you got, shop manual stuff from the manufacturer, and you need some support line stuff that you can talk to people about too. So it's basically a big community of helping everybody out, but the backyard stuff is limited in what you can do now. So anyway, that finishes that up. I just wanted to tell you a little bit.